Hello and welcome to today's webinar. Today we're going to be looking at exchanging OCS data with Ignition using MQTT Sparkplug. Let's look at our agenda for today. We'll start with an overview of today's demonstration. Then we'll do a quick review of MQTT Sparkplug, which is the protocol we're going to be using. We'll review the system components involved in the communications chain. There'll be demonstrations throughout, and we'll finish with a Q&A session. In today's demonstration, we will first publish data from an OCS that is performing machine control. We will then take the data published from the OCS and display it on a web SCADA program called Ignition. This will allow us to auto-discover the data that we're going to be publishing from the OCS, meaning we won't have to manually type in any variable or tag names. This also means we will be able to discover tags automatically and read and write data just by browsing. As well as this, instead of Ignition pulling data from the OCS using a traditional pull response protocol, the OCS will be pushing the data using MQTT Sparkplug. Now we'll do a quick review of MQTT. MQTT is a lightweight protocol, meaning it does not require a large processor or a lot of power to run. This means it can be used in devices that are battery operated and in devices that aren't very powerful. One of the reasons why MQTT is increasing in popularity is because of the increase in machine connectivity, Industry 4.0, also known as the Industrial Internet of Things. MQTT also uses a publish-subscribe model, which we will talk about in detail in a minute. Like many protocols and standards today, MQTT started out as a proprietary protocol nearly 25 years ago. MQTT uses a publisher-subscriber model instead of client-server, unlike protocols such as Modbus TCP. Publishers and subscribers don't directly talk to each other like they would with client-server. Instead, they communicate through a device called a broker. This means the publisher can publish data to the broker and the subscriber can communicate with the broker independent of each other. The data that is published is called topics, which is published at a rate that's appropriate for the application. This data is maintained by the broker. Subscribers or other devices that are interested in receiving that published information can then communicate with the broker and express their interest in that topic data. This means that instead of a client-server approach, where a single client will need to talk to every server, subscribers can talk to one or more brokers. Let's look at MQTT Sparkplug. One of the ways that MQTT is lightweight is that it doesn't define every element of the protocol. MQTT Sparkplug is designed to take the best of generic MQTT and add the necessary extra information to the specification, making it great for industrial applications. Some of the gaps that are filled in by Sparkplug include state management, so that a subscriber to data always knows that the data it's receiving from the broker is current, and that the publisher of that data is valid. MQTT Sparkplug defines payload as it specifies what data is sent and how it is formatted. It also provides a hierarchy and a set of rules there for how topics are organized. It also adds what's required for the auto-discovery of variables and tags. The components involved in a Sparkplug system are as follows. First, there is the MQTT Edge node. In today's demonstration, the OCS will be acting as the Edge node. The OCS will act as a piece of hardware that's directly connected to the MQTT infrastructure and publish the data. Then, the MQTT broker, also known as a server or distributor, will handle all the communications. With MQTT Sparkplug, there is also an MQTT host, typically a SCADA package, such as Ignition, which we'll be using today. This publishes and subscribes to messages similar to an Edge node, but is responsible for the SCADA type functionality and enables data that is published by an Edge node to be read by the SCADA program or host device, and then be turned around and written back to the Edge node. Finally, there are MQTT application nodes seen on the left of the diagram. These are other software packages such as historians, MES, and analytics, which are interested in the data being published and available at the broker. In our Sparkplug system today, we will have the following three components. Our MQTT broker will be a broker called Chariot. The MQTT host will be the web SCADA ignition, and the MQTT edge node will be a Horner OCS controller which is publishing the data from its control system. This demonstration will use version 8.1.2 of Ignition for Windows. The MQTT broker we'll be using is version 4.0.13. The final software component needed is an MQTT engine. This is a piece of software which allows the Inductive Automation web SCADA package to interface to the broker. For our OCS for this demonstration, we'll be using a 7-inch EXLW Model 2. We will also be using firmware version 15.64 and Service Pack 10 from Seascape version 9.9. The controller we'll be using has been licensed to support MQTT Sparkplug in the field with a one-time upgrade fee. Not all Horner OCS models support Sparkplug. Models that do include the X5, the XL OCS series from the XL4 onwards, all XL Prime series models, and all future Canvas models. Now we'll look at how to set up today's demonstration. We will begin by looking at the Inductive Automation's Ignition website on the home page. From here, Ignition can be downloaded. Today's testing can also be done using Ignition's trial mode, which runs for 2 hours. The MQTT distributor and engine needed for this demonstration can be found in the archive section of Ignition's download section. Once downloaded, select config and then modules. Here we can see all the modules that have been installed by Ignition. We can also see that we have downloaded and installed the MQTT distributor and engine from Cirrus Link Solutions in the version 4.0.13. Both of these components were downloaded from the Inductive Automation website. From here, now we're ready to do configuration. Under Config and then MQTT Distributor, we will go into Settings. Most of the settings shown are the default, except under Main, where the MQTT server has been enabled. Today's demonstration will use a non-encrypted connection to the server. However, an encrypted connection can also be used. Under Users, we can see where the user credentials are configured. Every edge node and host device will need to log into the broker. Here, there is a default set of credentials available. The username for this is admin and the password is changeme as one word. We can also see that there is read-write access to all topics through this login. Next, we'll look at the settings for the MQTT engine by selecting Config and then Settings under MQTT engine. Most of the settings are set to default except the MQTT engine which has been enabled. The block outbound edge node and block outbound device tag boxes under command settings have also been unchecked. This allows any topics and published data that comes in to be able to be turned around and written back to the OCS. Finally, we entered a primary host ID, which is needed if you have redundant brokers. This is when we have multiple brokers running, so in case one broker goes down or the connection to that broker has been broken, then the edge nodes have the ability to log into a different broker so that communications can resume quickly. In order to do this, we need a primary host ID, which we have called Chariot here. Next, we will select Servers. Here we can see the MQTT server, the username we're logged in with, and the connection status. This shows that the MQTT engine for Ignition is connected to the broker using this username. The URL shows the connection that is being made. Now we need to ensure the OCS can communicate to the broker. Next, we will set up Seascape so we can publish our data. Before we do this, let's take a look at our bench setup for today's demonstration. Here we have recreated a pump control system. We want to be able to report data such as water pressure and pump auto set points to Ignition using MQTT. Now we'll look at Seascape. To look at the MQTT configuration, we will select Program, then Messaging, and then MQTT. This is a 4-level configuration dialog. Under Controller, we will start with Status Register. Here we have created a variable called MQTT Status, which is an integer array of 52 values. The first element of this array is MQTT status with an index of 0. Next, we've created a Boolean type variable that will enable MQTT communications from the OCS when turned on. The client ID should be a completely unique identifier for any node that's reporting data. To ensure that we have a completely unique identifier, we can use the Ethernet MAC address for the OCS that's reporting the data. Because client ID is a text or ASCII type field, we will put that MAC address in between single quotes. Next, we will look at the things to configure that are going to basically help organize our data that we're reporting. The group ID is the textual name given to the group of nodes reporting data to the broker. Here we have named this Horner. Next, we have node ID, which we have named pump control as we're doing pump control in today's demonstration. To support any redundant brokers, we are going to give the primary host the same name as we did for the MQTT engine configuration. Next, we need to configure the connection to the broker. We will select broker connection, ignition broker, and then edit. So this is just a convenient name and it doesn't go out over the wire. Here we have made the connection name ignition broker. Next, we have the IP address for our broker. A URL can also be used here. As mentioned earlier, this demo is unencrypted. This is a standard port number for unencrypted MQTT. For the username and password, we are using the default credentials for the MQTT broker, which are admin and password change.me. Sparkplug defines a way that subscribers to data can know that the publishers of data may be down or that the data they're looking at is invalid. This happens through a keep alive. So as the OCS is publishing data to the broker, we will be sending data periodically. If we won't be publishing data frequently, we can configure a keep alive which will send signals to the broker. For Sparkplug, we also need to ensure that clean session is checked. If we were doing an encrypted demo, we would also have to configure the page under encrypted. Finally, we have to decide what data we'll be publishing, what topic names we will give to this data, and how often we are going to be publishing that data. To do this, we will look at topic configuration. Here we have a list of all the topics that have previously been configured. When we select our broker, we are able to view the details for this topic. The topic can be seen as a folder where our variables and tags will be organized under. For our demonstration, we have named the topic pump, so if a subscriber subscribes to the pump data, they will be able to see the metrics in the list of variables below. So anybody that subscribes to the pump topic is going to get all of this data. With QoS, we are able to control the quality of service. Here we have set this to 1. Periodic allows us to choose how often we'll be sending data. For this demonstration, we are sending it once per second. With our configuration complete, we'll look at our bench setup. In the bottom left corner of the OCS, we can see the MQTT enable/disable button. When enabled, we can see the status is now 15. There are 4 bits in the first status word for MQTT status. So if each of these are on, this confirms that our configuration is valid and that we are successfully communicating with the broker. Now we'll return to Ignition. Here we can see the page for our current project. In the bottom left corner, we have the tag browser where we can browse all available tags for our project. Let's take a look at the MQTT engine. Under Edge Nodes, we can see our group ID that we called Horner. Under Horner, we can see the node ID pump control from the OCS that's transmitting the data. If we had made multiple nodes in the Horner group ID, we would see them under here. Under pump control, we are able to view node control, node info, and any topics we have made, which in this demonstration is pump. Under pump, we can see our list of variables and live metrics. To take the pump out of automatic, we can uncheck this box. If we return to our bench setup, we can see the upper left-hand corner of our OCS that our pump has switched from automatic to hand mode. Returning to Ignition, we can also change our set points. We'll change our onset point from 58 to 65. Now if we look at our bench again, we can see in the lower centre of our OCS that the onset point has now changed to 65. We are now successfully publishing data from the OCS to the broker, and both the OCS and Ignition are talking to the broker and exchanging data. This data is two-directional because Ignition is acting as the host server. The data that the OCS is publishing can therefore be written back to the OCS. That concludes our webinar for today. Thank you so much for listening, and the Q&A session will begin shortly.